Math 34 students. This is Module 3, and we're going to look at Example 1 on page 76. Remember to make sure that you have read the vocabulary on page 75 because we'll be using that vocabulary in these examples. So this table in Example 1 gives the number of Florida boat registrations over here in the boats column in thousands, and the number of manatees killed by boats in Florida over here in the manatees column. We also have the year column that corresponds with each of these events. So the years help us organize this information, but we won't need to use it to find our regression equation. So we're investigating if there's a correlation, and remember from your vocabulary on page 75 that a correlation measures the direction and strength of this relationship, and we're looking specifically if it's a linear relationship. So we're looking for a correlation between the number of boats and the number of manatee deaths. Okay, so investigating the explanatory variable, we remember the explanatory variable is what causes the change. So in this case, we suspect that the boats are causing the manatee deaths. Okay, so we've written this up that number of boat registrations is the explanatory variable because we suspect the boats cause manatee deaths. Our next question is which column will be the response variable. So remember, the response is the outcome. So in this case, the number of manatees killed by boats is our response variable. Okay, so we have here that the number of manatees killed by boats is a response variable, and we can say this is because the number of manatees killed is the outcome of the number of boats. In part C, we're using Excel, or you could use your TI graphing calculator to create a scatter plot to compare the data. Then we're going to find the regression equation and the R value. Remember, R is the correlation value, and write it in the space below. So in Excel, I have uploaded the Module 3 data, and if you come on the bottom sheet to Example 1, you'll find the data from the table is already typed in. So you can download this file from Desire to Learn. So we make a regression line in the same way that we do a scatter plot. We're going to highlight all of our data. We're going to choose scatter, and remember we're in charts or insert chart depending on which version of Excel you're in. So see up here on the tab we're in charts. And I'm going to choose the first scatter plot choice. And we can see the data here real clear. And then I want to see the regression line. So if you go into the quick layouts, you can scroll around and see the different choices, and you can try some of the different choices. One of the layout choices has a line on it and also f of x right here that tells us, it gives us a regression function. So if we click on this, over here on the chart has popped up our regression equation and our R squared value, and I'm going to drag it out so that it is real clear to see over on the side, and I'm even going to make my font bigger and bolder. So here's our regression equation. y equals 0.1177x minus 36.28. And remember, the regression is the line of the best fit for the data. And so what the computer is doing is averaging all these distances apart of all the data points, and it's finding the line that fits the best, so gives the best average distance for each data point overall. And we chose linear regression, so our graph is a line here. Visually, it looks like a pretty good fit to the scatter plot. And we see our R-squared value is 0.88413. Now remember, we want to look for the R value, so we're going to have to take the square root of this number to see what it is. So let's go back to our activity packet and record this information. So our regression equation is y equals 0.1177x minus 36.28. And then we've got r squared. This is how we type on the calculator with the caret 2 to show it squared, is 0.8843. So now to find the r value, we're going to have to take the square root of this. So on your graphing calculator, you can square root this, or you can pull up the computer calculator. And when we square root it, we get 0.94, and then if I round it, it'd be 0.3. So in general, if you're unsure, go ahead and go to 4 decimal places. That's a good rule of thumb for our class. So the slope here is 0.1177. And now we want to remind ourselves, what units is this? So remember, we're measuring manatee deaths in the y-axis as our outcome, and boats are our explanatory variable, or the input. So this is 0.1177 manatee deaths per 1,000 boats, because remember that we are measuring the boats in terms of thousands. Our R value is R equals 0.9403. And R, you can use capital R or lowercase r. You'll see that I oscillate between the two. Question E is asking us, is there a correlation between the number of boats and number of manatee deaths? And how do you know? Well, our R value is R equals 0.9403, which is very close to 1. We have a positive R value because, if you remember, our graph had a positive slope. If your graph had a negative slope, then you would have negative R values, and you would look to see if it was close to -1. So since the R value is so close to 1, it looks like there is a strong correlation. So this means that the more boats, the more manatee deaths occur. Because it's a linear relationship. So question F is asking, do you think there's a causation between the number of boats and the number of manatee deaths? So there's a little bit of opinion in this question when we ask about a causation, but because the manatees are specifically listed as being killed by boats, there does appear to be a causation because of the strong correlation and that the manatees are killed by the boats. Now remember, correlation doesn't always imply causation. Sometimes we can graph and compare two things that are unrelated and get a correlation. It doesn't necessarily mean one causes the other. In this case, it seems pretty clear that the boats are killing the manatees. Now question G wants us to use our regression line to extrapolate the number of manatee deaths there would be if there were 150,000 boats registered in Florida. So remember, in our equation, our regression line, X is representing the number of boats in thousands, and Y is the number of manatee deaths. So in our equation, we can say Y equals 0.1177, and then in place of X, we're going to go ahead and put in the number of boats. So now remember, the number of boats is in thousands. So when they ask about 1,500,000, we can go ahead and cross off 3 of these zeros and just plug in here 1,500 because it's already measured in thousands. Okay, now you go ahead and type this into your graphing calculator and figure out what our projected or predicted number of manatee deaths is. So our total here is 140.27, and that's manatee deaths. So let's finish up with a summary sentence. So our regression line predicts, or extrapolates is our vocabulary word, that there will be around 140 manatee deaths if there are 1,500,000 boats registered in Florida. Okay, let's go ahead and look at example 2. This is page 78. And in example 2, our data talks about the Congo in Central Africa in 2002 and 2003 had a deadly outbreak of the Ebola virus, and it killed 91 out of the 95 gorillas in 7 different home ranges in the Congo. So a gorilla group's home range is the region that the gorillas in the group travel each day to get food and supplies. So biologists have classified the gorillas into the home ranges. So our table here is including the number of home ranges separating the group of the gorillas from the first group infected. So how far away they are in terms of home ranges from that first infected group. And our second row is the number of days until the deaths began in these groups that were later infected. So we think that the number of home ranges is going to affect the number of days until the deaths began. So our explanatory variable is the number of home ranges, because we think that the number of home ranges affect the length of time until deaths begin. So when we're thinking about the explanatory variable, that's very similar to the x variable, and when we do the regression equation, the explanatory variable is usually in the x place. The response variable, or the outcome, in this case will be the number of days until deaths began. And this is because the number of days until the deaths began are the outcome of the distance away the gorillas are. right? We believe the distance is causing the days till death. Okay, this is a very grim example here with these gorillas dying. For part C, we can make a scatter plot and find the regression equation and R value. I'm going to go ahead and use Excel to do that. So if you come back to Excel, down on the bottom tabs, open example 2 if you download the module 3 data file. And I have put in here the data already from our example. So we're going to go through the same process. We're going to highlight our data, go to Chart, choose Scatter Chart, choose the first example, and then go ahead and on your chart layouts, pick the one that has the function and gives the R squared value. And then we're going to go ahead and make this bold and a little bit bigger so you can see it better. And then we'll go ahead and record on page 78 here our regression equation in part C. And we can also record our R squared value and use that to find the R value. So we can go ahead and take the square root. And remember, you can round to 4 decimal places. Another way to find the correlation is to go in Excel and type in correlation. And then you could do A2 colon A7, and then you could say comma B2 colon B7, and that ought to give us the correlation. No, it didn't. Okay, maybe we need to say coral. Yeah, and so you type in coral in your formula, and that's another way to get the correlation. You can check if you take the square root of 0.92609, that'll give you this R value correlation right here. So we'll label this as our correlation. So remember the formula, you can see it up here, is coral. You don't have to type out the whole correlation. Let's go back to our activity packet and record these results that we found. So our regression equation is y equals 11.263x minus 8.0877. And remember, the regression equation is the line of best fit. It's not a perfect fit, but it's the closest. And then we can say the correlation is R equals 0.9623. And again, you can find this by taking the square root or by typing that coral function into Excel. So is this a stronger correlation or less strong than the Florida boat manatees? Well, here our correlation is 0.96, so this correlation is closer to 1. So it is a stronger correlation than the Florida boats and manatees example. Both are very strong correlations, but our R value here is in fact closer to 1. Question E is asking is, do you think there's a causation between the number of home ranges separating the gorilla groups from the first infection and the number of days? So it does make sense that distance could affect the deaths. And the time it takes for deaths to begin. So we do believe in this example that there is a causation. Again, there might be instances where we don't see any causation. Okay, so this is the end of example 2. In our next video, we'll pick up with example 3.